Assalamualaikum warahmatullahi wabarakatuh. So today our group 9 that consists of Nur Syuhada binti Abdul Hamid, Nur Fatihah binti Ramli, Ahmad Zaidi bin Zakaria and Amir Aznan bin Ali Rahman are going to present about the attachment 2 and attachment B assignments. For the attachment 2, this part are going to be presented by Nur Syuhada binti Abdul Hamid and Nur Fatihah binti Ramli. Meanwhile, for the attachment B are going to be presented by Ahmad Zaidi bin Zakaria and Amir Aznan bin Ali Rahman. So now I would like to pass the presentation to Sister Syuhada and Sister Fatihah for the explanation on attachment 2 assignments. Thank you.
Thank you to Brother Zaidi. So now Syuhada and Fatihah will discuss about the modeling and simulation of nanoparticle separation through a solid state nanopore. Separation technique such as polymeric gel or chromatographic column is widely used to separate the molecule in chemistry. However, researchers use molecular dynamic stimulation in determining the suitable parameter to be used in separating these particles using nanopores. However, there are 5 limitations were found while designing a new device. It will be discussed further throughout the session.
Okay, for the first limitation of molecular dynamics, it is found in this journal that molecular dynamic simulation is suitable for smaller computational domain with spatial dimensions on the order of 100 nanometer, and it has very short time scale. So in order to solve this first limitation, the researchers of this journal use container-based models for electrokinetic transport of charged, cylindrical, and spherical particles through nanopore. This model uses a few equations in order to determine theoretically the parameters that are suitable to run the experiment of separation the two particles. Some equations used in this model are Nernst-Planck equation, which is used to calculate the net transport of ionic species of an electrolyte. The Poisson equation, which is the equation to determine the electric potential distribution in electrolyte, and Navier-Stokes equation, which used to calculate the flow of incompressible electrolyte. For the next limitation, it is the existence of the Brownian force motion, as this particle separation was run under electric field. So during the determination of parameters based on the continuum model using the equation mentioned just now, they found that this model showed the existence of Brownian force motion as in the equation shown in the slide in the white box. So the equation shown in the white box is Langevin equation, which used to calculate the particle motion in the electrolyte suspension, as this separation process was implemented in electrolyte environment. The Brownian force motion is a random force motion that felt by particle that being exerted by surrounding solution. In order to solve this Brownian effect existence limitation, they use a variable time steps which can avoid the Brownian force motion. Then they found out that as close to the pore where the separation process will happen, the electrokinetic force is much bigger than the Brownian force. Okay, this electrokinetic force is one of the force in the Langevin equation, which is FEI. They found that the small time step can be used to determine the location of the particles. Time steps is a very important parameter, as this can help human to determine the sample phase space fastly and save on computer expense. The next limitation is it is found that this model accuracy is strongly depend on the merge size. The merge size is a very important parameter in the separation process through pore. Thus, to solve this limitation, they use finer merge near the charged membrane surface so that the subtle change in the potential, ionic concentration, and velocity can be captured accurately. I'll pass to Fatihah back.
So the next limitation is related to the location of the particles. To calculate this, quasi-steady method was used. So the last limitation is the overall particle velocity trend is same for both particle, but the translocation rate is lower for particle B due to the lower particle charge density and its larger size. To distinguish, in order to In order to distinguish both particles, a best fit line had been drawn to identify the magnitude and type of pore surface charge density for zero particle velocity at the center of the pore. Okay, it can be seen from the figure below, figure A. The best fit line indicates the particle A have net zero velocity at pore charge density 6.23, while the particle B at 3.64. Membrane surface charge density must be set in this range to achieve the aspiration. Additionally, to increase the efficiency of dispersion, particle B should not come close to the particle A by preventing the particle B from reach within 200 nanometer to the pore. Therefore, membrane pore surface charge density for particle B between 6.58 and 3.79. To conclude, there are 5 limitations that were found in order to design a better separation particle device which are related to the molecular dynamic. All these limitations have its own solution and really need to be considered in order to produce a perfect device to be used in the future. I think that's all from us. I will pass the floor to the brother Ahmed and Zaidi. Thank you.
Okay, thank you, Sister Shuhada and also Sister Fatiha for explaining about the attachment 2 regarding the limitation of molecular dynamic and how to overcome the limitation. So now me, Ahmad Zaidi and also Brother Azlan are going to explain about the attachment B, which is we were given with the data of 809 different Pokemons and also the ability of type 1 and also type 2. However, if we can see here, the Pokemon, all of the 809 Pokemon have only type 1 and ability, and while for type 2, there are some of them didn't have the type 2 ability. So later we are going to answer two questions, which is question A and also question B. And for the question A, we are going to use a pivot table, which is more systematic and readable for our question to answer. So in this pivot table, we can see that the table, which is the row represents the type 1 ability, meanwhile the column represents the type 2 ability. If we can see at the right side of the table, the grand total shows the total number of type 1 ability, which is for the bugs is 72, which is all of the bugs, all of the Pokemon that have bug ability. Total are 72. Meanwhile, uh, for the type 2 ability, only 5 Pokemons that have the type 2 bugs ability. So, from this table, we can see the value in this table represent the Pokemon that have the combination of type 1 and type 2 ability. Next, I will pass to Brother Aznan to continue with the questions.
Thank you, Brother Zaidi. So I'll be telling you how we got the answers for the questions. So for question 5A, we were supposed to find out what is the number of grass type 1 Pokemon, which is also poison in type 2. So from the pivot table, we could see from the grass row for the type 1 and the poison for type 2 in the columns. And then if we right click the data, right click the
I'm sorry for the technical issue.
if we right click the data and press show details, we could see the Pokemons which have both the combination of both grass and poison type. So for the next question, question B, we want to find out what is the difference between number of type 1 Pokemon which has type 2 ability and type 1 Pokemon which doesn't have type 2 ability. So from the table, we sorted it so that each of the Pokemons at the top contains type 2 ability, and we did this by selecting the original data table. If you go to the original data set, You select the headers and all the Pokemons, and then you right click, and then you sort arrange, and data has header row, and you click type 2. Then you could see how it's sorted in alphabetical order, and the Pokemon type 2 abilities is at the top. So from the in this table we've sorted it, and then based on the Pokemons, we can use an if function on the fourth column. We can use an if function if the Pokemon has both types of elements. We put yes as the answer. If not, it'll have a no. If I decided to go down, you can see that yeah, over here there's no, if there's no type 2 elements, there'll be no, whereas if there is, there'll be yes. And then from that column we can make a pie chart, and yeah, we could see that there's 404 Pokemon